All right, welcome to another edition of Middle School Geometry. And what we've got today is exploring angle relationships. So you'll see that there is no Mathia screen up right now. And that is because there are some notes for this that it would be beneficial for us to take prior to beginning any of the work in Mathia. And I am going to skip past some of the notes at the top in my notebook here, my digital notebook, because I started with writing some stuff at the top and then decided to add to it, so I put it later at the bottom. So we're actually going to start near the bottom of our list of notes today, and you can go ahead and put these at the top of your page because this is where I really wanted to start, but again, kind of ran into a snafu because I wanted to add some things. And so to start with, folks, we're going to be talking about the stuff that I am putting inside of sort of an orange box. We'll be talking here first. And I'm going to go through this pretty quickly, so feel free to pause. What would be probably most beneficial is just to listen first, then pause when I get done talking about this section and take the notes. But listen first and then take the notes after you listen to understand what we're talking about. So our first thing today is this idea of a thing called supplementary angles. And supplementary angles have a sum of angle measures that is 180 degrees. And so in the purple, if we look at this example right here that I circled in purple, we have angle ABC and angle DBC are supplementary because 110 plus 70 is 180. So those two angles, when I add their angle measures together, makes 180. That means that they are supplementary. You'll notice that those two angles are sort of stuck together. They share the vertex B and they share the side BD. So supplementary angles can be stuck together like that, or what we will call later adjacent. Being adjacent is sharing a vertex like vertex B and sharing a side like how it shares side BD. So supplementary angles can be adjacent or stuck together, and as long as their two angle measures add up to be 180, they are supplementary. Now, going down to the second example, which I will box in red, we have two angles that are not stuck together. So they are not what we would call adjacent. They are just kind of out there floating on their own. We have angle XYZ and we have angle PQR. 85 and 95, if I add those two together, does make 180. And so they are supplementary even though they don't even touch each other. And they are not adjacent. They don't share a vertex and they don't share a side. So supplementary angles can, like our first example, be stuck together or adjacent and add up to be 180, or they can be out there on their own, like our second example of 85 and 95. Those two add up to be 180 as well. So those are also supplementary. Okay, now would be a great time to pause and take notes about supplementary angles. I'm going to move on to complementary angles. And you can see on my screen, it's almost time for geometry tutoring. I will probably have to pause this video to start my tutoring session. All right, so complementary angles are what's up next, and that's this whole page full of fun right here. So complementary angles are sort of like supplementary angles, and their definition is the same, except instead of the sum of angle measures being 180, the sum of the angle measures is 90. And the way that I remember which one of these is which is that if I was to do alphabetical A, B, C, whatever, C comes first. Complementary starts with C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. Supplementary comes second. So I remember that complementary is 90 because it comes first in the alphabet, and supplementary is 180 because it comes second in the alphabet. And if I was to count from 0, I would get to 90 before I would get to 180. So that's just a simple way to remember the difference between complementary and supplementary. Complementary comes first in the alphabet. 90 comes first if I'm counting. Supplementary comes second in the alphabet. 180 comes second if I'm counting. So just like before, we will look at our example here in orange first. We have angle XYR and angle RYZ. And those two angles are complementary because 35 plus 55 makes 90. Those two angles are also adjacent because they share a vertex and they share a side. So complementary angles can be adjacent or stuck together. As long as they add up to be 90 degrees, they are complementary. Moving down to example 2 here, we have two angles that are not stuck together or not adjacent, angle ABC and angle LMN. ABC is 20 and LMN is 70. Those two add up to be 90. So 20 plus 70 makes 90. That means that those two angles are complementary. Okay, I'm going to pause the video for 1 moment and scroll all the way back up to what is at the top of my notes. Again, this is probably going to be the top of your notes, but I'm going to pause for 1 moment to scroll up. Now would be a good time for you to pause and take notes on complementary angles. All right, so beginning my video again, you can see I've kind of scrolled up here back to supplementary and complementary angles. Used to be up here. I moved them to the bottom so that I could add to them. But I've got adjacent angles defined here. So adjacent angles share a common vertex and a common side. And that's something we talked about in both supplementary and complementary angles a moment ago. But it is a situation where the angles share a common vertex and a common side. So if we look at, in this example, angle ABC, which I sort of highlighted there with a little green angle, it is adjacent to both angle, and I'm going to go ahead and erase my oranges right there real quick so I can draw them with you here. So ABC, that green one right there, is adjacent to both DBA. And we see it's adjacent to DBA because they share this side, and they have B as a common vertex. It is also adjacent, ABC is also adjacent to angle CBE. We can see that ABC is adjacent to CBE because they share this common side and they share the vertex B. So an angle can be adjacent to more than one angle at a time. Because it has two sides, it can be adjacent to two different angles. What I do want to point out at this point is that, I'll do this in green, this angle right here, ABD, and this angle right here, CBE, are not adjacent. They do share a common vertex at B, but they do not share a common side. Those angles are something different that we will get to in just a moment. So again, adjacent angles share a common vertex and they share a common side. I'll stop right here so you can pause to take notes on adjacent angles, then I'll move on. Okay, next up for us is a linear pair. And so I'm going to actually add to this definition now that I have given it some thought as I've started kind of talking through this. But a linear pair is two adjacent angles that form a line. So a linear pair is two adjacent angles that form a line. They are also supplementary because a line is 180 degrees. And so linear pairs are always going to be supplementary because they make a line, and a line is 180 degrees. What I want to point out is that unlike supplementary angles, let's pretend that this angle here was 95 degrees and this angle was 85 degrees like in our example earlier. These angles, even though they are supplementary, are not a linear pair because they do not visually make a straight line. So for a pair of angles to be a linear pair, one of the key things is that they have to be adjacent. And so we can see that angle ABD and angle DBC are in fact adjacent because they share the common vertex B and they share the common side BD. So these are a linear pair because they are adjacent, and they are also supplementary because they form a 180-degree angle, which is a straight line. One more time, just for clarity purposes, circling in red, these two angles are supplementary. They make 180 degrees, but they are not a linear pair because they do not share a side and a vertex. They are not adjacent. They do not make a straight line visually. All right, moving on to our next piece, vertical angles. I think this may be our, nope, we have quite a bit more here. Okay, I'll come back up here and give you a moment to pause and take notes before I go down. I need to remember to do that. Okay, vertical angles. I love vertical angles because they are super helpful for a lot of stuff that we are going to be doing later on. So vertical angles are non-adjacent, which means that they don't share a side. They may share a vertex, or actually in this case they have to share a vertex, but they don't share a side. So non-adjacent angles formed by two intersecting lines. So if we come down to our example, circled in orange, another way to say that is that vertical angles are opposite of each other. And they are also always congruent. So let's take a look and identify some vertical angles here. So see this angle SRT right here that I'm kind of coloring over in purple? It is 50 degrees and it is opposite of the angle PRQ. Notice that they are both 50 degrees. That's because vertical angles are always congruent. And so it's two angles that are basically opposite of each other that share a vertex. They are always going to be congruent. Those are vertical angles. Now, if we also look at our other example that I have, angle SRP, that I'm sort of highlighting in green here, is a vertical angle to angle TRQ. Those are both 130 degrees. They are vertical angles. They share a vertex. They are opposite of each other, and vertical angles are always congruent. So vertical angles are pretty simple, but they are super duper helpful as we move forward. So I will pause and give you a moment to take notes before I continue. All right, we've got 3 more angle measures here. I need to pause the video for one moment because it is 10:45, so I'm going to open our Zoom and be meeting with you folks on Zoom while I continue recording this lesson. All right, so Schlegel is back, and I've got my Zoom meeting open for our Wednesday class session, but I'm going to continue teaching this thing while people kind of come in onto the Zoom as well. So we've got 3 types of angles listed here, and you may recognize a couple of them from elementary school. You probably talked about acute angles when you were in elementary school and obtuse angles. So acute angles, people remember that, oh, they are so cute because they're little, like little puppies, they're small. They are less than 90 degrees. And so an acute angle is an angle that measures less than 90 degrees. That's likely a bit of review for you, but it's worth mentioning. And an obtuse angle is an angle that measures greater than 90 degrees. So there are some very simple examples drawn there. Obviously, the top 3 under acute angle are less than 90, and the 2 listed under obtuse angle are more than 90. And then lastly, rounding out our notes for this section today, we have a straight angle. So a straight angle is an angle that measures 180 degrees or is a straight line. Okay, I'm going to pause myself there for one moment, give you some time to take notes or to pause.